Okay, now we are on question 5. So the question 5 is very related to question 4. You start at rest and accelerate at a certain rate a for a time t. The other one said for a distance d. And the final velocity is v. If you accelerate at 4a, okay, for a time t, your final velocity will be what? So in this case, the times are the same. So what does the picture look like? Well, this person is accelerating at a for a time t, but the distance we don't know. The other guy is accelerating at 4a for the same amount of time. Well, if you accelerate 4 times as fast for the same amount of time as the other guy, you're going to travel a farther distance, right? So this is the same time t. If the final velocity here is v, what's the final velocity there? So the question is saying, what will be your final velocity? Will this be twice that? Will it be 3 times that? 4 times that? Okay. So what equation do we use now? Well, we say this one. V final is v initial plus at, right? V initial is 0. So if you accelerate for a for a time t, your final velocity is going to be at, right? And then if you accelerate 4 times as much for a for the same time, what's your final velocity going to be? Well, it's just going to be 4at, right? And since at is equal to vf, at equals vf, so vf prime equals 4vf. So the velocity here will be 4. So since you're accelerating for the same time, your final velocity is exactly 4 times as much as if the velocity if you had accelerated for a time t. So the answer is 4v. As a matter of fact, if we wanted to, we could also find the relationship of their distances. What's the distance here? Well, we use the other equation. V final squared is v initial squared plus 2ad. Right? We used this in the previous problem. If it's 4 times as fast, then you 4 squared. You go 4 v final squared, okay, divided by 2a is equal to the distance d. Right? So since the velocity here, vf prime, and we have here, we're going to put a prime, right? So in other words, I want to know what is the ratio of the distance. How far, what's the distance here compared to the distance there? So vf prime, that's 4vf quantity squared, okay, divided by 2a prime. Okay, what's the ratio going to be there? So we could actually erase this here. So the distance d, and we can call this d prime also, because the distance is different, right? So d prime is equal to 4vf quantity squared over 2a prime. 4 squared is 16, vf squared over 2. The acceleration is what? Well, the acceleration a prime is 4 times the acceleration of the other case, right? 4a. So is equal to, I'm going to put 4 goes into 16. Since this is 4 goes into 16 4 times. And then we have 4, and then what is this? Vf squared over 2a. Vf squared over 2a. So you have final velocity squared over 2a. That is equal to the distance. So distance d prime is equal to 4d. Okay? So if we want to explain now more conceptually why this is happening, in the first case, you have this person accelerating for a for a time t. The other person is accelerating 4 times as fast. Their time is also the same. So during that same time, they're going to cover 4 times the distance. Okay? 4 times the distance. So it will look like this, something like this. 1, 2, 3, 4. Okay? Same time, 4 times the acceleration, 4 times the distance as this one here, d, 4d, and then their final velocity will be 4 times the velocity of that guy's velocity. Okay? So that's why in this case it was 4 times the velocity. In the previous question, it was only twice the velocity because the time was shorter. Okay, so we'll now go to the next question.